All right, so we're given the integral 2 pi from 0 to 8, y plus 3, radical 8 minus y dy. So we're trying to analyze this type of integral. I can totally tell you that this is an integral that's obtained by using the shell method, because this tells me that you have 2 pi here, you have p of y, and you have h of y dy. Okay, and p and h could interchange, but we have to be smart enough to sort of like look at this carefully. Okay, again, this could be also h of y and p of y. Okay, we have to think about both scenarios. Okay, but obviously we're going to choose the most relevant one. Okay, um, so I think let's start with p of y, h of y type representation. So the height is radical 8 minus y. We have the thickness dy. Okay, so p of y is y plus 3. So if I were you, I would just like plot x equals 8 minus y to start with, and to see what kind of graph it is that. Generally, h of y uh, for a slice for well, when you take a slice, generally the height of the slice is determined by the curve. That's why it's better to look at x equals 8 minus y. And you have y plus 3. Generally, y coordinates of those slices are taken as like y. So if this is y plus 3, I will consider y plus 3 as y minus 3. So in other words, so this is going to tell me exactly where or what axis or what line I'm rolling the region around. Okay, so y equals -3. So I think we should plot x equals radical 8 minus y and y equals -3 to see what the region looks like. I think we're going to do the axis. We are going to have the axis of revolution to be y equals -3, and see what the region looks like. And the bounds for the for y values would be in fact 0, y, and 8. Okay, based on what the given integral is provided to us. Okay, so let me just show you what I got here from my end. Okay, so the blue curve here is x equals uh, radical 8 minus y. I have the y equals -3 purple horizontal line. Okay. Okay. So this looks to me like we were taking a slice, since we assume that the axis of revolution is the x-axis. Okay. In fact, y equals -3 vertical line, not the x-axis, but y equals -3 horizontal line. Okay, so that means that I'm going to label this as like y, the distance from the slice to the x-axis. So the corresponding height of the slice here by the way, that makes the uh, radius of the bottom portion of the shell to be exactly equal to y plus 3, because this distance from here to here is 3. So as you see that the whole radius is going to be y plus 3. And that's what I got in the integral, right? Whole radius to be y plus 3. Let me show that to you. Yeah, whole radius p of y to be exactly equal to y plus 3. So our like intention was true to start with. And obviously the height of the shell is determined by the x coordinate of this point here. Okay? So assuming that the y coordinate is y, so the x coordinate is going to be radical 8 minus y. That's exactly what the age of the shell is. Okay, so this setup is correct, and the axis of revolution is y equals -3. So the plane region is the green region bounded by the blue curve, x-axis and y-axis. So I can go back and clean this part up and just say like the plane region is the region bounded by x equals 0, y equals 0, and x equals 8 minus y. X equals 0 means y-axis, y equals 0 means x-axis, and the blue curve in the previous slide, that's x equals radical 8 minus y. Okay. Identify the axis of revolution, that's exactly y equals -3. Okay. I think this is the only setup that you can go with to get that integral written for representing the volume of this green region revolved around y equals -3. You can think about the other scenario, but that's not going to work probably. What I'm trying to say is, like, you can consider this one to be h and this one to be p of y. But when we have the axis of revolution horizontal, and if you're using the shell method, um, this is probably not going to work because you have to label something like y. Generally, the height of that, uh, sorry, not the height, but the distance from the slice to the x-axis, and that determines the radius. And radius should not have the radical sign. Okay, so the radius here should not have the radical sign in it. It should be something involving y, but in a linear way, not in a square root or cubic root way. Okay, so I think this setup doesn't work. And then you should probably go with this one to be p of y, and this one to be h of y. So this is a nice inverse problem because generally we're first given the region and the axis of the revolution, and we determine the integral to represent the volume, right? But this is sort of like the other way around. We're given the volume integral and then asked to find the plane region and the axis of revolution. That's that's an interesting question in that regard. If I were you, I would just consider some other. I would just practice some other exercises in the textbook to see if you are able to pinpoint the plane region and the axis of revolution. But I think this is the end of the video. And thanks for watching. And I'll see you in another video.